We begin by adding every positive whole number, 1 plus 2 plus 3, and so on, forever. In standard arithmetic, the total simply grows until it reaches infinity, but advanced mathematics assigns this specific infinite sum a finite value, -1/12. This result is accurate. It is a strictly proven mathematical conclusion used in physical models of our universe. It originated with Srinivasa Ramanujan. He was a government clerk in colonial India with no university degree and no formal training. He famously claimed that his equations were not his own. They were dictated to him in dreams by a Hindu goddess. Understanding how an untrained clerk derived this impossible fraction forces us to question where mathematical truth actually resides, and whether it is something we create or something we simply find. In the early 1900s, Ramanujan lived in Madras, isolated from the global scientific community and the rigorous traditions of European mathematics. He taught himself from a single book of theorems that listed results without proofs. This trained his brain to jump straight to the truth of a number, bypassing the traditional steps of logic and verification. By 1912, he had filled notebooks with thousands of dense, proofless results. Most mathematicians dismissed his letters as incoherent, but one eventually reached G.H. Hardy at Cambridge. Hardy initially suspected a fraud, but he realized the formulas were too complex to be invented. They possessed a deep internal structure that even the greatest mathematicians in England had never seen. Ramanujan saw mathematical architecture where others saw noise. When Hardy dismissed his taxicab number, 1729, as dull, Ramanujan replied instantly that it was the smallest number expressible as the sum of two cubes in two different ways. The absence of traditional academic boundaries allowed Ramanujan to see structural truths that a standard education likely would have filtered out. So, how does that intuition lead to -1/12? How does a logical system extract a negative fraction from a sequence of growing positive integers? The answer lies in Ramanujan's summation. Standard arithmetic asks what numbers add up to, but Ramanujan's summation asks what finite value is most naturally associated with a specific series. First, the Grande series averages to 1/2. Next, an offset subtraction of alternating integers equals 1/4. Finally, subtracting this from our original infinite sum forces the difference to become a direct multiple, equating to exactly -1/12. This is not a magic trick. It is a mathematically consistent alternative to basic arithmetic, and it turns out the universe actually uses it. But does this equation have a physical reality, or is it just a clever manipulation of symbols on a chalkboard? In bosonic string theory, this sum is a requirement. To calculate the dimensions in which a string can vibrate without breaking the laws of physics, theorists must sum the vibrational modes of the string. That calculation only works if the sum of all integers is -1/12. Ramanujan derived this specific result decades before string theory was even conceptualized. We see it again in the Casimir effect. When two metal plates are placed close together in a vacuum, they experience a measurable attractive force. Predicting that force requires summing quantum vacuum energy modes. Ramanujan's calculation provides the exact value that matches our physical measurements. This logic is now a foundational tool in modern quantum field theory. When physicists normalize infinite quantities in the calculations running through particle colliders, they are using the mathematical bridge Ramanujan built. The impossible equation written by a clerk in a colonial office is part of the code that governs the quantum architecture of our universe. Ramanujan never claimed these universal truths were the product of his own deduction. He insisted they were shown to him by the goddess Namagiri. His time in England was a period of rapid discovery, but it destroyed his health. He was lonely, malnourished, and ill with tuberculosis. He returned to India and died in 1920 at just 32 years old. He spent his final months filling a lost notebook with theorems that mathematicians are still verifying over a century later. Ramanujan's life suggests that the most complex laws of reality are accessible through pure human intuition, predating the technology we eventually built to prove them.